My talk's actually entitled Perils and Highlights of Error Monitoring. So real quick before we get started, and I do want a show of hands if you feel comfortable. How many of you, one, know what error monitoring is? Cool. That gives me hope. We might actually make it through this. The next question is, how many of you are using error monitoring on the front end in production? That's significantly less hands. Okay, we'll get there. So, like Tanner said, I've been a software developer for 8+ years. I've had the opportunity to work in a bunch of different industries, and the unique thing about my career is I've worked, well, not in this area, but in the general world and population, I've had the opportunity to work at incredibly small startups. We're talking teams of no more, entire company, 12 to 25 people, which allowed me the opportunity to learn a lot really fast and make a lot of mistakes so you don't have to. Like Tanner said, I'm a father of 2 lovely little ladies that can be a pain. I'm a tinker and a maker, if you want to use that term. That's great. A tinker and a maker. I love 3D printing. So if you want to nerd out on 3D printing, I've already done it with 3 or 4 of you, and we'll get there. We can talk about it. I'm an avid rock climber. If you can't find me, chances are I am anywhere from 100 to 200 feet up on the side of a cliff. And an interesting tidbit is I'm a former competitive ballroom dancer. It's how I met my wife, and we actually competed, and that was the career plan until we had our first child and realized if we did that, we would die broke. Everybody. So I had to change careers very quickly, which worked out for the best. We still get to do it for fun. So let's get into the actual bulk of my talk. So how many of you have written an error? Everyone in this room should absolutely raise their hand. If you haven't, you either started yesterday or you're lying, okay? So we all know that errors are inevitable. We can't foresee them. We don't know they're coming. They just happen, right? That's why they're called errors. We don't intentionally write bad code, at least I hope not, and we don't intentionally introduce these errors. However, they still happen. So we're going to talk a little bit today about mitigating them and about what we do to prevent them, right? Error monitoring is the way we do that, but traditionally, errors, when they happen, are reactive. So something happened, oh no, Garrett broke prod again, what did he do? We have to go in and figure it out. It takes hours worth of debugging, hours worth of time, usually not just my time. Usually I have to pull somebody else in, and there are colleagues in the room here that understand the pain of having to work with me to find an error. And we have to work together to find this error. That's downtime, that's taking and cutting into our sprints. They're a pain. They're a pain. It takes a ton of time and effort and energy, right? So I'm going to pose the question, who is responsible for keeping apps error-free? And remember, I'm a father, so there are a lot of dad jokes in here. Can you spot the error? Dadgummit. All right, everybody cross their fingers and toes that we make it through this without just absolutely losing the screen. But I'm just going to hold this then and stop moving. So who's responsible for keeping prod error-free? Is it QA? Is it DevOps? Or is it the developers? I have a theory. It's our job. There are a lot of memes in here. By the way, these memes do not reflect the ideas or philosophies of my employer. They're just funny. So, if you broke prod as a developer, it's your responsibility to fix it. I hear the term, and I hate the term, shift left. If you don't know what that means, it's a way for DevOps to not do their job. It's a way for them to shift it back to us, right, as developers. So all code has errors, and I actually agree with them. It's the dev's responsibility to handle it, but we have a ton of other responsibilities. We have not only our sprints, we have to write tests, we have to plan, we have to prepare, you can keep adding to that list all day long. We don't have enough time. We don't have enough time. So how are we going to add in bug hunting, like we're going on a safari through the jungle of code that we just wrote, to be able to find that error? And this is kind of what that, if you guys aren't familiar with it, and I hope it resonates with the audience, that's Bender. And all they were trying to do in this episode was get him to do his actual job, just once, right? And you as developers, it is your job to deal with the errors. It is your job to prevent the errors, and it is your job to ensure they either come out of production if they're there, or don't make it to production in the first place. And like I said, there's a whole bunch to worry about. And when you start adding in different application architectures, specifically microservice architectures, and we'll get there in a second, things get incredibly more complicated. The more complicated the system, the more complicated the error, and the more complicated things can become. And when I say error, we're not talking about one error. Usually errors don't happen in an isolated incident where you have one instance on one session with one user and all of a sudden error. If you do, we should talk because I believe you've achieved status of deity, because I can't do that. They come into thousands and thousands, right? So let's get into it, right? Let's take a journey into some of my experiences, because that's all I can relate to, of some things that I've worked on in some microservice applications and architectures, and why error monitoring is important, and how, to a point, how, or rather the why, we should implement error monitoring. So, I got skipped too far. Application number 1. This was actually my third job at my third company, and it still haunts my nightmares, right? So this is a company that was fintech. It's leading, and I've worked at a couple of fintech companies, but it was lending as a service. So the way this application was set up is they built it for their first customer on a basic platform that was built on a node, and I use the term node loosely here because it kind of was. They had a node application that was using a framework that wasn't fully fleshed out. They were using about 4 versions too old of that framework. And what eventually ended up happening is every time we added a new customer, rather than creating a new application or branching off of that or creating, I don't know, a service that ran in the background that we could call things from different customer front ends, they decided they were going to copy, paste, clone. Sorry, my P-pops are really bad today. Copy, paste, clone the entire application, start to finish, all the way through, and create a brand new application from all the old bad code that was still working and roll it into production, which was great. It was fun. Sarcasm in the voice there. We rolled about 35 of those. So we have 35 applications, all using weird archaic code bases that all decided they were going to take this one root trunk and branch off into a bunch of different applications that all had their unique needs, because heaven forbid we use a common endpoint to be able to call, I don't know, the same things as a credit check. Weird. Instead, they had to do it all their own, right? And I understand some of that is some compliance there, but it was using a system, like I said, I can't say the name of the stack, but that ship needed new sails, hint, hint. And it was terrible. So every time we had an error, and we didn't use error monitoring, by the way. This is a what not to do example. Absolutely zero error monitoring. I would argue that QA had their hands full, would be an understatement. But anytime an error occurred, it came through our tech support from our client. We would know about it about a day and a half later. And by that point, the site had been down for hours. We had one that was down for days and nobody checked, right? We didn't have anything running to check it for us. Not even infrastructure monitoring, which is a huge no-no. But every time we found an error, not only would we have to change it in that one unique application and pray that it was the unique part of that application that went wrong, because then we only had to fix it once and not something at the root. Because if it was at the root, we had to go do it 35 times. 35 different deployments, 35 connections of bringing databases down, bringing them back up. It was fun. This is where I learned there's got to be an easier way. I don't need to cry at work every day. My goodness. So I left. Kind of. I left and the company shut down 3 weeks later. Surprise, surprise. But after I left, I got back into my wheelhouse. And essentially what I got into is started looking at microservices, which I was introduced on the back end and then got introduced to microservice front-end architectures. And we'll talk about those here in a second. But I got to go play around with some of the stuff I loved. For those of you who are super big UI nerds, I got to finally mess around with design systems, which I highly recommend you look into. They're really cool. So, application number 2, my first real job out of college. This application, they brought me in as an intern. I got to build their website, and they're like, that's good. And Now we're going to build a new UI. I was like, cool. They're like, here you go. Go nuts. Pick a framework. We don't care which one. Get after it. And they gave me a lot of rope to hang myself, which was awesome because I had to learn really, really quickly. So what we ended up deciding, me and another intern there, who was a colleague of mine, which future, if I'm ever a CEO, don't give interns full reign of your UI. That was a bad decision on their part, but as a developer, I'm super grateful for it. We decided we were going to roll a component library and use that component library to be imported into different pages that were being self-served so that we could use what we believed at the time was a microservice architecture, right? Library separate with all your components, similar to, at the time, I guess it was, lost it, Twitter rolled it. Thank you, Bootstrap. See, that's why we have a group of engineers here. So it was similar to Bootstrap, but it had its own personal functionality, its own designs, things like that. And we worked with a designer to do that. It was really fun. So the application actually ended up looking like this, except for there weren't teams. We called them projects, and we broke it up. Problem we ran into is we didn't put in error monitoring at the start, right? So one of the situations that we had is we'd have our internal library, and every time we made a change to that internal library, we'd have to deploy whatever page or application was using that specific component, right? So that's 2 deployments, not that bad. Usually things didn't go wrong. We were doing okay. It was pretty good. There were hiccups here and there. By the time I left that company, we had started to go think about implementing that error monitoring system or any form of application monitoring to be able to get uptimes, to be able to get things like that. But this worked out really well. And this is actually one of the legitimate strategies that a microservice architecture can take, is having a component library that has all of the shared data in it, or all of the shared applications, components. Once those application components are utilized, anything that utilizes them needs to be re-rolled. Otherwise, we don't have to redo it. But error monitoring is key to make sure, because one thing we learned is it's not really that hypothetical, but hypothetical situation, I mess up on the header bar and I roll that application. Well, the page can't load because that's the first thing that loads, so whole page is down, right? I mess up on the footer, I may load other components, but since the way we were loading them, the header wouldn't come in, right? So not only do I have one component that could go sideways, it could take down the rest of them. And it was really hard to narrow down in context which components were causing the problem. So we spent a lot of our time debugging. And I really hope this talk doesn't come off as me being a bad developer, because I was still in a learning stage. So we made a lot of mistakes. However, I think that's the best way to learn. So a system that could track context and the context of your application and see which components are causing which problems or throwing which errors would have been incredibly helpful. Moving on. Why? Okay. Don't hit the space bar. The next one was a real estate application. I'm sure some of you are familiar with this real estate company. I won't say names. Awesome company to work for. Still love them to death. And this is not the representative of the little girl who, lit her house on fire. That is not our experience there. This is no way reflecting that company. However, there were days I did feel like this between you and me. So we had this real estate application that we were taking from a monolithic application into a bunch of different microservices. Not my idea. I came into that situation, and it gave me an opportunity to work in a different team-based pattern, right? And so let's talk about that team-based pattern. Every section managed itself, managed its own state. The things that needed to interact, interacted. Things that didn't. We also had on top of that parts of the first structure where we had that internal library as well. So we would, if one or more of these applications, or two or more of these applications used that library, we would then, or needed a component, we would then move it into the library and write it into the library. Super nice. Tough to transition from a monolithic architecture to a bunch of microservices. However, this is essentially what it looked like, right? So we had this single page application that sat underneath a edge router, and you had a bunch of teams running a bunch of different product pages. And this is where I learned the value of error monitoring. We implemented an error monitoring solution that was native to Azure, right? Application Insights, for those of you who are familiar with it. And it allowed us to narrow down very quickly which components had which errors. what the context was. And every time we got an error, our time to complete or time to turnaround shrank significantly from all my other experiences. I was actually blown away at our ability to turn something around, write code, and push it out in a deploy almost same day. Very rarely did I think we go over, and I can be corrected on that for those of you who are my colleagues. But usually we'd have a fix out incredibly fast. It was awesome. It was amazing to work with. The one thing that I missed there is that the context of state for some of these things coming in, so if we had one in let's say the internal library, wasn't there. I couldn't see what the user was doing at the time that the error was caused, specifically on the front end. That would be super valuable at that time. And now I moved from that company to here, where I work mainly with relations teams, so I don't get to build nearly as much as I would like to. But as I've got to move on, we run into a problem, right? The problem is, this is great, this is cool, this is awesome. We figured out error monitoring is a good thing, let's go ahead and implement it. But how do we make sure that we can continue to develop for the future and still have that error monitoring, right? So let's get into the little controversial future. And this is probably my favorite meme here. It says, we replaced our monolith with microservices so that every outage could be more like a murder mystery, right? This is what we typically see in microservice architecture systems, right? So let's talk a little bit about federated modules. So we've gone over 2 strategies for microservice architectures and kind of how error monitoring can relate to them, right? When you get into a federated module, and I did not create this. This is actually I have the source for it somewhere. This is actually a diagram created by somebody else that I found on a blog. But now we have an architecture, an application, where instead of it being same application, same framework, running underneath an edge router, we can actually use whatever framework we want. We can use whatever state manager we want, and we can wrap it all using Webpack 5 to create these federated modules. Now what that does is it allows that application to componentize and get really, really, really small, right? It's a single use principle. It does one thing, and it does one thing really well, and it's running live. So when we need to deploy, we just redeploy that component. And then your home application, which would be running on something like single spa, that's what that icon is down there at the bottom, would just accept that change. As long as the contract between those 2 application components didn't change, we're good to go. It'll pick it up. So you change a color, I no longer have to redeploy the entire application. I redeploy that component, boom, we're done. Now, the cool part about that is with systems that we have now and error monitoring that we have now, we can wrap every single one of those components in error monitoring, right? And inside of that error monitoring tool, we can see context for what the state did. We can see clickability. So what did the user actually do on the front end? To see, give us a little bit of breadcrumb trails to see they clicked here, they entered here, they clicked here, they entered here, they entered here, and then they hit submit and my application exploded. We can follow that path all the way through to see what actually changed inside that state, because each one of these pieces is maintaining its own state and talking to the overall state manager. So not only can we wrap our state manager inside of, for React, which is what I'm familiar with, it's called an error boundary, and wrap that inside of a tool like Airbreak. We can actually point it at that specific error boundary and say, hey, if anything goes wrong in here, catch it, tell me what they did, where they came from, and what the state was at that moment. To be able to narrow down and shrink that time to give our customers the best experience. So there are a ton of different error monitoring tools you can use. I have an affinity towards one. You can guess what it is. But other ones are, or I'll just go roll off a list. There's Rollbar, Datadog, we've got Sentry, we've got Airbreak, we've got a massive one called Logic Monitor that does infrastructure monitoring, and these monitor both front end and back end, right? But the key here is up to you guys. Error monitoring is your responsibility. I don't care which one you use, wink, wink. It doesn't matter to me, to be honest with you. As long as you understand the principle behind it, as long as you understand it's a tool to help you and help your users. Get error monitoring. So once again, how many of you are using error monitoring in production? How many of you should be using error monitoring in production? Every hand in here should go up, right? So the idea there is, once again, it can only help you, right? And I know this sounds like a sales pitch. I'm not trying to be sales pitchy. These are the lessons that I've learned doing it the hard way. You don't want to be where I was when I worked for that fintech company. You don't want to be changing 35 different applications and doing 35 different deploys. These error monitoring tools are so powerful, we can narrow down not only the line of code, the function, and the state. We can tell you which deploy it was deployed in, and if any of your dependencies have changed, right? So everybody should be using error monitoring. Go home, talk to your bosses. If you need help convincing them, I know a guy, okay? So, moving towards the future with a federated module, moving towards the future with a monolith, no matter what architecture you choose, you can shoehorn in application monitoring and error monitoring to make your lives easier. It's automated. It'll take things off your plate, and your bug time shrinks. So you can go back to doing what you really love to do, which is building cool stuff, right? So, thanks for coming. I know I'm long-winded, but I really do appreciate it. Anybody who wants to can join the Airbrake developer community. If you currently use Airbrake, please do this. I would love to hear what your gripes are, what you want to see, what you love about it. And this is the sales pitchy part. Please join that. If you want to, you can go ahead and follow me. I'm not that interesting of a guy. I don't post a lot, mainly when I travel. But if you want to, I'd love you in my network. Thanks again, and thanks for your attention and time.